Alright, grade 9. Hope you enjoy my daughter video. Sorry about the echo effect, but in any case today our goal is simple. We are going to solve question that has multiplication, division in an inequality. We're going to look at some pattern first. This is available in your booklet to Unit C, Equation and Inequality, not the linear relationship one. So let's investigate some pattern, okay? For example, I want you to look at your example that is given on the table at the very top. 8, is bigger than 4. We all know. But what if we multiply both sides by 2? Then you will notice 8 times 2 becomes 16. 4 times 2 is 8. Is this still valid? Yes, it is. I want you to give it a shot. You may pause this one and do, or you can go along with me. It really doesn't matter. Let's look at my example over here. 5 is smaller than 20. Okay, so I gotta multiply both sides by 2. 5 times 2, that's 10. 20 times 2, that's 40. Is it still alligator mouth open up towards the right side? Yes, it is. So I like to say it is valid still. What about the next one? 8 times 5, that's 40. 4 times 5, 20. Same direction that is open. Yes, it is valid. Same thing happened. Now, what if I multiply by negative though? This one I'd like to elaborate a little bit. 8 times negative 2. 4 times negative 2. Alligator mouth was originally open in this way. 8 times negative 2 means negative 16. 4 times 2 with negative, that becomes negative 8. Is this still a valid condition? Negative 16, is that still bigger than negative 8? The answer is not in that situation. In fact, if you think about, the condition need to rather change so that it's open up the right direction towards negative 8 instead of negative 16. What about this one? 5 times negative 2, that's negative 10. 20 times negative 2, that's negative 40. Is this right side open up condition still valid? I like to say no, because to make it valid, you need to change up the direction towards the left side, because negative 10 is bigger than negative 40. If you continue this activity, you will find some pattern. 8 times negative 4, that's negative 40. 4 times negative 5 is negative 20. Even though it's open up the left side, you will know that it's not valid. What about if it's division? 8 divided by 2, 4 divided by 2, it's 4 and 2. Is this still valid? Yes, it is. What about if it's negative? 8 over minus 2, 4 over minus 2. This gives you negative 4, negative 2. It's not valid because theoretically, as I mentioned, yes, the alligator mouth was open up towards the left, but because we're divided by negative number, theoretically this should make sense more. Same thing happens, right, when it comes to the last one. 5 divided by negative 5 is equal to negative 1. 20 divided by negative 5 is equal to negative 4. Even though the alligator mouth was open towards right, this is invalid because I have to open up toward left, so it is not valid. So now here's my question. How did multiplying and dividing, or multiplication or division by any type of constant number, how does that affect the inequality? Sometimes it's valid, sometimes it's not valid. I want you to think about that rule a little bit in your head. So we have a condition. Solve the following inequality, use a number line and graph each solution. Negative 3x smaller than equal to, which is located over here. And we have negative 12 as condition. Now, here's first thing that I need to do. You may notice that solutions, there are a lot of solution inequality. In fact, solutions are more of a range. How many answers that you can have. It's gap between the boundaries to boundaries. So what we need to do is isolation. We isolate using reverse operation or inverse operation, same thing. Right now, can you see negative 3 and x? They're multiplying each other. So what's the opposite of it? I gotta divide. Here's what's gonna happen. Negative 3x, what I need to do is I have to divide it by negative 3. Now that means x will be gone. So here's what happened. X, and I'm not gonna put any symbols yet, on the left side, and on the right side we have negative 12 divided by negative 3. Did you notice that I included the sign? In this case divided by negative 3. Then here's what happened. The symbol that you had in between, which indicates smaller than equal to, you need to reverse that direction into this way. Then simplify. X is now bigger or equal to negative 12 divided by negative 3, which is 4, positive 4. So if I were you, 1, 2, 3, 4, 5, this is what I'm gonna color, and x is anything bigger or equal that is my solutions. You can verify this too, ladies and gentlemen. Verification is always needed. How can I verify? Well, pick any number that satisfies this condition. X anything is bigger and equal to 4. So why don't we pick 5? Because that satisfied the condition. And I substitute inside of this original condition. Sorry, I'm just going to erase to show. Original condition that we have. Negative 3 times 5. That gives you negative 15. Which means negative 15 smaller than equal to negative 12. Is this condition still valid? Yes, it is, because negative 15 is smaller than negative 12. That's how we verify inequality situation. Let's do another example. This time I'm going to show you a little easier method. It's kind of like cutting the corner, if you will. First of all, did you see that I have negative and right side I have positive? You can change up the sign by multiply by negative 1. What I mean by that is negative 1 is just a fancy way of showing you can multiply by negative on both sides and change up the direction of the alligator mouth in between as a starting point. So what I mean by that is this. Negative k over 3 will turn into positive. Whatever the one that you see, open up to the left, change it to open up to the right, and positive 2 turning into negative 2. We call this like switching the sign. It is still inverse operation a little bit too. If you struggle, multiply by negative 3 over here. But once you have this modification, you now are okay with the symbol in between, which is a bigger or smaller sign. Only thing that I gotta do is opposite operation. I can multiply by 3 on both sides so that the bottom number will be gone. So k is smaller than 3 times negative 2, which is negative 6. This is my condition. So 1, 2, 3, 4, 5, 6. Not a solid circle, empty circle. Anything that's smaller than that is my solution, negative infinity. How can we verify? Pick any number again. I will pick something that is multiple of 3 just because the bottom number is 3. So why don't I decide k is equal to minus 9. Then let's substitute this in to this expression. Negative 9 over 3 minus is what I have on the left side. If I simplify these guys by dividing by 3 on both top and the bottom, you will have minus 3, aka positive 3. So 3 bigger than 2. Is this condition valid? Yes, it is valid. So our solution, which is the gap in here, anything that's smaller than negative 6 for x, actually work. You can deal with positive and negative sign anytime. This time I'm going to speed things up. Divided by negative 4, x. By the way, because I divided by negative number, direction should change. 8 divided by negative 4 should be negative 2. So if this is 0, anything that's smaller than negative 2 should be my solution to infinity. How can I verify? Pick any number that satisfies this condition. What about x is equal to negative 3? Because it's smaller than negative 2 after all. Then negative 4 times negative 3, the original expression is saying that should be bigger than 8. Negative 4 times negative 3 is positive 12. Is this condition valid? Yes, it is. That's how you solve. So, ladies and gentlemen, that was today's lesson. Your homework part is from textbook. This is Math Link 9 to be specified. I think it's chapter 9 also. You can double check. It literally has inequality as a title. I want you to do question number 7 everything. When it comes to 9 and 10, just do B, C, D. Number 13 and 14, I believe one of these are word questions. So just for the heads up.